Moving on to page 3 of section 1.2, we're going to take a look at a definition, and the definition involves y-intercepts and x-intercepts. The first definition, the y-intercept of a function is the point where the graph of the function crosses the y-axis. That means that when we have a y-intercept, the x-coordinate is 0. So the process for finding a y-intercept is set x equals 0 in our function rule y equals f of x. This means that the y-intercept is equal to f of 0. So in other words, to find the y-intercept at x equals 0. And when you're in a function rule, that means plug in the value x equals 0 into your function rule. Part B of definition 3 says an x-intercept of a function is a point on the x-axis where the graph of the function crosses the x-axis. So the x-intercept, which is also known as a 0 of our function, the x-intercept happens when then we're going to have y equal to 0. And so y equals f of x equals 0, which means that if we have a function rule, we're not going to plug a 0 in and evaluate what the 0 in all of the variable spaces. We're going to take our function rule, which represents y, and set it equal to 0. And then we have to do some algebra to solve for x. Now, example 5 gives us a graph. The graph does not have a function rule to go with it, so we're just going to read our domain, range, and our function values that go with these function rule inputs off of this graph. So, for example 5, for the function given, find the following: the domain and range. I'm looking at my graph and I notice that it's not continuous, meaning there is a break in the graph as I trace it, but I notice that where it's not continuous, the closed dot matches up with the open dot along the line that goes through the x-axis, the grid line, that goes through the x-axis. So the domain does not have a break in it because this closed dot fills the open dot, and it continues on into infinity. All right, so from left to right, the domain, the x value starts at, our scale is quarter scale, meaning each of these grid marks it is a half scale, meaning each of these grid marks is equal to 1/2 of a unit. So right here, that point is -1 on the graph, and then this is -3 on the graph where it intersects down here. X equals -3 and y is whatever that point is, and this point is -5. Moving to the right of 0, our break in the graph that's filled with the closed dot and the open dot is at x equals 1. And on the other side of 2, there's our x equals 3. We finish with x equals 5 on our scale here. Likewise, on the y-axis, it's not the same scale. The y-axis is by units of 1. So 1 hash mark or grid mark is just a full unit. So we have 1, 2, 3, 4, 5, 6 going up the y-axis, and then units going down the y-axis. Once again, always check the scale. Always check the scale of the graph that you're working with. So now finding the domain, going from left to right, the domain starts with a closed dot for an x value of -5. The y value, at this point, I'm not interested in it. I'm just left to right along the x-axis, starts at -5. We have this break that gets filled, So the domain does not stop at 1, it just keeps on going at 1, and along the x it keeps going to infinity. We know it goes to infinity because of that arrow. For the range, all right, the range is along the y-axis. So we're going to be moving along that y-axis from the lowest to the highest. And as we move along the y-axis, once again, looking at our graph and scanning left to right, we notice that our graph has a lowest point here and a highest point there. And between the lowest and the highest point, there is a solid line all along, which means the range does not break, because this line right here continues graphing along these y values, even though there was a jump from this closed dot to that open dot. So the lowest point on our range is -4 for our y value, and the highest point on our range is +4. Now, evaluating these points, f of -3, this is an x value. X equals -3. So we go to -3 on the x-axis, and then we're going to drop down to the function, and it intersects the function right there, and we trace it back to the y-axis, and that happens at -2. F of 2, we go across the x-axis to +2. So we move across the x-axis, we move up to the y, and we intersect right here at y equals 3. Once again, these are y values. Function values are y values. And then f of -4.5. -4.5 is, as we move, is right here. As we move along the x-axis, -4.5, trace up, it intersects the function at that grid mark, and that is the grid mark of 1. So when x is equal to a -4.5, y is equal to 1. And we are to now estimate values of x for which f of x equals 2. So we are estimating x. We were given y. So now along the y-axis, we find y equals 2. And we have two x values where y equals 2. We have an x value of 1. If I go to the right, we have an x value of 1. And if I go to the left, we have an x value of -1. What that means is that f of 1 is equal to the y value of 2, and f of -1 is equal to the y value of 2 as well. Now we are to find the y-intercept and the x-intercept. The y-intercept is where it hits the y-axis, which happens to be at its highest point in this particular graph. So the y-intercept is at x equals 0, y equals 4. The x-intercept happens on the x-axis, and it's where it hits the x-axis, and there happen to be two of them. So I'm going to estimate this x-intercept right here, and I'm just going to say -1.5. So at -1.5, it's on the x-axis, so the y value is 0. And then another x-intercept right here happens at -4. In example 6, we are to find the x and y intercepts of this rational function. Now, when we work with rational functions, we have to pull out a lot of our information regarding how to work with fractional equations. So to start off with, when you have a fraction, let me just remind you, you cannot divide by 0. If you divide by 0, it's undefined, and that results in a vertical asymptote on a graph. So on a function, whatever happens to be in the numerator, if you divide by 0 in the denominator, then you have an undefined point. and you end up with a vertical asymptote. If you have a 0 on the numerator and you divide it by something, I'm going to say the b represents what we're dividing by, and the b that we're dividing by does not equal 0, then we end up with 0 over b equals 0. And then finally, if you have a fraction, if you have something that is written in the form of a over b, and let me throw in some information, a does not equal 0 and b does not equal 0. So if you have a fraction of a over b, and we happen to say, oh, by the way, a over b is equal to 0, what that means is, from this rule right here, if you have 0 over b equals 0, and a over b equals 0, then a must equal 0. Now, why would I go over these fraction rules? Because this intercept, you set the y equal to 0, your rational function equal to 0, a equals 0, the numerator, goes back to this part right here. So, to find an x-intercept, you set the numerator equal to 0. And then you solve for x. To find a y-intercept, it's really quite simple. To find a y-intercept, if you remember from our previous definition, it has to do with plugging in a y. So I'm going to write it over here. To find a y-intercept from the previous definition, you plug in x equals 0. If you happen to get this guy with a 0 in the denominator, that's not an x-intercept. Okay, we can't have a 0 in the denominator. Most of the time with the function that we're looking at right now, you plug in your 0 and you'll be left with some fraction that you need to reduce to its lowest terms, and you have your y-intercept. Now, with all of that given as a review of how to work with fractions, let's now find the x and y-intercepts of this particular rational expression or equation. So the y-intercept, x equals 0. So that means f of 0 equals 0 squared minus 6 times 0 plus 8 divided by 3 times 0 minus 2, which these values go to 0, and we're left with 8 over negative 2, which is negative 4. So the y-intercept happens when x is 0 and y is negative 4. The x-intercept is going to happen when the numerator equals 0, because we have x squared minus 6x plus 8 over 3x minus 2 equals 0. And as long as we're not going to get a value that takes our denominator to 0, on this other side, this 0 could be divided by anything. So that works out to x squared minus 6x plus 8 equals 0. Now, if you factor this, it's fairly quick. We're looking for the factors of 8 that add to a negative 6. So the factors of 8 that have the same sign, and when you add them together, you get negative 6, and that's negative 4 and negative 2. You end up with x minus 4 equals 0, x minus 2 equals 0, x equals 4, and x equals 2. So the x-intercepts happen when y is equal to 0, and the x values are 2 and 4. Now we can do this on our calculator as well. If we take a look at our calculator, we can plug in our function, and all I'm interested in is the numerator. plug in our function x squared minus 6x plus 8, hit graph. And on our graph, we can see visually by inspection that it intersects the x-axis at 2, which x equals 2, and 4. Likewise, by inspection, we can see that this parabola crosses up here. And before we become confused, that's not the y-intercept that we got. And that's because this is not the graph of the rational function. The rational function is x squared minus 6x plus 8 divided by the quantity 3x minus 2. If we want to check our y-intercept, we can go back to our calculator. And let me do y equals again. And let me put this in fraction form. Okay, just clear that, sorry. Fraction form, and where I just enter all of this back in. So the numerator is x squared minus 6x plus 8, and the denominator is 3x minus 2, and hit graph. Ah, lovely. So we can see some asymptotes happening here, and you think, as we look at this, it's really hard to tell on this graph. There's our x-intercepts, okay? And then our y-intercept is happening right here, where y is equal to -4. So when you're checking your graphs to make sure you did this right, or you're using your graphs to see if you're going to get these intercepts, it's important to be aware of what you have plugged into your y equals. Now, if you just wanted to use your calculator to do this, it's might be a better choice. So if you just want to use your calculator to do this, just plug in your rational function. Make sure, once again, you have a calculator. You don't have to. I'm sorry, let me go back. It's nice if you have a calculator that will stack your fraction like this. If your calculator does not have the latest operating system, you may have to use some parentheses to get the graph to work. Now, we have it in, so we're going to graph. There it is, nicely graphed. And we can find the x-intercepts. Is hard to see through a variety of methods. I'm just going to do the 0 function, and I'm going to find the x-intercepts, also known as the zeros of the functions, by moving my spider along my graph until I get close to one of them. And it wants to know the left bound of the x-intercept, so I hit enter. I move over to the right of the intercept, and I hit enter, and it wants a guess, and I hit enter again. So I have a 0 at 2, 0. There it is. And then if I want to get the other 0, I'm going to do the function again, second trace 0, number 2. And I'm going to trace till I get just to the left of where I think it's crossing the x-axis, and to the right. And my guess is at 4, 0. If you couldn't see that those were intercepts, you can do a zoom. And I like to do a zoom box, which is number 1. And to do a zoom box, you move your spider along the x-axis. You're just moving freely along the grid. And you're going to create a box. So I usually anchor the left corner, top left corner first. So I'm going to move my spider to about right there, and I'm going to hit enter. And it's going to drop a square, which means it's anchored there. And then I'm going to move until I get to the other side of where I think it may be hitting the x-axis. And I'm going to drop my box. So I anchor the top left corner of the box, and I move to where I think it's along the x-axis to where I think we've hit the x-intercept. And then when I say drop the box, I'm going to press the down button on my calculator until I get the bottom right corner of the box. I'm going to hit enter. and then it graphs that region for you so you can really see, yes, it's hitting the x-axis at 2 and 4.